Today's video is going to cover graphing what we call piecewise functions. So piecewise functions are going to have multiple pieces on the graph, unlike a line that has only one piece. If we look at example number 1, we're going to see two different equations. That tells us we're going to have two different pieces to our graph. So here's what you're going to do. If we look at that top line, the way we find y is with the equation x plus 2. That only happens, though, when x is greater than 3. The bottom line is telling us to find y, we're going to use negative x minus 1. That only happens when x is less than or equal to 3. Okay, so if x is less than or equal to 3, I'm going to start with 3 and then get smaller than that. To find y, I need to plug those numbers in. So if I plug in 3, I get negative 3 minus 1, which will give me negative 4. Negative 2 minus 1 will give me negative 3. And negative 1 minus 1 will give me negative 2. Okay, if I have less than or equal to, that's going to be a closed circle heading in the other direction. So I know this is confusing, but stay with me. I'm going to graph those points. So I have 3, negative 4. I have 2, negative 3, and 1, negative 2. And I'm going to graph them going this way. Okay, so then let's look at the table that's on the left. This says x is greater than 3. Whatever this number is, that's always where your table starts. So x is greater than 3, I know, but we still need to include 3. Don't start at 4. So that's the biggest mistake people make, is they start at the wrong number. Greater than 3 will be 4 and 5. You don't have to choose 4 and 5. You have to choose any numbers that are bigger than 3. If I plug in 3 to this equation, I get 3 plus 2, which is 5. 4 plus 2 is 6. And 5 plus 2 is 7. Now in this case, 3 is not included. We have x is greater than 3. There's no equal. So this is going to be an open circle. So now if we graph these, we have 3, 5 with an open circle, 4, 6, and 5, 7. There's only one open circle. So if you think on a number line, you don't put multiple opens. You put one and then you shade. And then once we connect these, we get the other piece of the graph. So that is one example of a piecewise function. I know this is confusing, so we're going to do another example together. And let's look at example 2. Okay, this example 2, like you can see, is going to have 3 pieces. We have these 3 lines right here. The equation is always for y. So we have y is equal to negative 4. We have y is equal to x plus 1. And we have y is equal to 2x. Okay, and then on the right, we see the values of x. So we have x is less than negative 2. We have x is between negative 2 and 2. And we have x is greater than or equal to 2. Okay, so we're going to fill out all of these together. If we start at the table all the way on the left, as we said before, this is the number where your table should start. So it's going to start at negative 2, and we're going to get smaller than that. Now think on a number line. Smaller than negative 2 is negative 3 and negative 4. We talked about in the previous problem, if a number is not included, so there's no equal sign in our inequality, we have an open circle, and then heading this way. Okay, now in this case for y, our equation is saying y is always negative 4. At this point, I'm going to graph this part of the graph before I go on. So I have negative 2, negative 4, which is an open circle. As we talked about above, there's only one open circle though. So only that one will stay open. Everything else is going to be closed. So negative 3, negative 4, and negative 4, negative 4. And that's our part. we're going to skip the middle for a minute and go to that table on the right. So again, this number is where we start. So we're going to start at 2 and get bigger. This time for y, we get 2x. So 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. 2 is included, so that's a closed circle, and we are heading towards 4. So in this case, 2, 4 is closed, 3, 6, and 5, 8. 4, 8 rather. That's the second part of our graph. Now we still have another part. So this one's going to be a tiny bit different. You are always going to include the two numbers on the outside. So I'm going to need a -2 and a 2. And I'm going to pick any number in between. So in this case, I'm going to include 0. -2 is a closed circle because we have the equal sign. 2 is an open because we don't have an equal sign. And then we need to plug in for y. So it's x plus 1. -2 plus 1 will be -1. 0 plus 1 will be 1. And 2 add 1 will be 3. So now we need to graph this. -2, -1 is an open circle. 0, 1 is closed. And 2, 3 is closed. And that's our second piece of the graph. Okay, a quick check for you all. If you graph this correctly, your graph should be a function. So if you remember from earlier in the chapter, a function means if you put a vertical line through, it's only going to pass through once. So what I always see is I always end up with students that have a graph that looks like this. You know that's not a function. If you put a vertical line through, it passes through twice. So if you ever have parts of your graph that are crossing over, that wouldn't be a function. So that's not going to be right. Okay, I think we need to do, you all need to do some examples without me. So we're going to look at the next page. Example 3, I would like you to try. I'm going to fill out the table for you or start the table for you, and then I want you to try the rest of the problem. Here's your y's. Sorry, not this one. So we get y equals x, and we get y equals 1/2 x plus 3. Here, x is greater than 0, and here, x is less than or equal to 0. So right now, I want you to pause the video and take a few minutes to try this one on your own. Okay, let's see how we did. For this first table, you should have started at 1 and gotten bigger. Or started at 0 and gotten bigger. 0 is an open circle. And here it says y is equal to x. So whatever x is, y is going to be the same number. So 0, 0 is open. And then we have closed, closed. So remember we talked about on a number line, the first circle is open, but then we shade. So you shouldn't have open circles the whole way. For the second one, we have 0, and we should have gone down. Closed circle heading in this direction. And then plug in. If I plug in 0, I get 3. If I plug in -1, I get -1/2 plus 3, which is -2.5. Oh, or +2.5. And then if I plug in -2, I get -1 plus 3, which is 2. So 0, 3 is closed. -1, 2.5. -2, 2. And again, you should have noticed that your branches of the graph don't cross. That's good. That means you're on the right track. So we have one more that you're going to try, and it's this example 4. So this example 4, you are going to do on your own and turn that in for class tomorrow. I would like us to look at this last example at the bottom. It says, using your equation from example 4, not 5, evaluate the following. Okay, so f of negative 4, this says that x is equal to negative 4. Now, if we look at our equations above, I don't want you to plug negative 4 into every single equation. I want you to plug x equals negative 4 into the appropriate equation. So we need to look at our bounds here, or our domains. Here is negative 4 less than negative 3. Yes, we're going to use that equation then. So we get an equation or an answer of 1. If we look at this, x equals negative 3. Is negative 3 less than negative 3? No, so you're not going to use that equation. So we need to figure out, where does negative 3 fall? It falls in here, right? Because we have that equal sign with the x. That's where you want to plug negative 3 into then, is the equation. So we get 2 times negative 3 plus 1. So negative 6 plus 1 will give us negative 5. And then for that f of 5, this is our value of x. So again, where does that x fall? Falls here. 5 is greater than or equal to 3. So plug in x equals 5 here, and we just get 5 again. I cannot stress enough, you are not plugging in the x value to all 3 equations. You should get 1 answer for each question, not 3. For class tomorrow, you need to have your notes turned in, including with this example 4. So if you need to go back and re-watch part of the video, please do that. If you have any questions, please ask. Good luck, and I will see you in class.